Hi there, you're welcome back to my channel. So in this video, I'm going to take you through integration by parts. In our previous lessons, we've done integration by substitution and by partial fraction. So under integration by parts, I have two problems here for us to solve. So first of all, let's see, what's the whole concept of integration by parts? Remember that in differentiation, whenever you are given two functions being multiplied by each other, or we say when you have a product of two functions and want to find the derivative, we say that you differentiate one and you leave the other, plus you leave the other, then you differentiate one, right? So this is it. So in a situation where now you have a derivative, sorry, in a situation now that you have the integral of the product of two functions, how do we solve this, right? How do we solve this? So in order to solve the integral of product of two functions, you only have to express one as a derivative and one as what do you say, as an integral. I mean, you just divide it into two. So here all that you are going to do is you just make any of these a subject, right? So you say that u prime of v will be equal to uv all prime minus uv prime, any, okay, any is right, any of them is right. So let's see something here. For the first problem, integral of s cosine x, right? The x. So once you have s cosine the x, what happens? Here, you simply have to get your u and your v. Is that not it? Your u and your v. Okay. So for this side, I didn't finish. Okay. So what you are going to do is you are going to take the derivative on both sides, because I said derivative. We're going to take the integral, because we want to find the integral of what? The product of two functions. So here, when I take integral, so let me do here. Let's say, let's cancel this. Right. So here, see, for us to simplify this was the differentiation aspect. Now, what about integration? I'm going to take integral on both sides. uv all prime is equal to integral of u prime v plus integral of uv prime, right? So at this point, this becomes uv is equal to my integral of u prime v plus integral of uv prime. So now you can make any of these two the subjects instead. Okay, so integral of u prime v will be equal to uv minus integral of what? Uv prime. And that's what we call integration by parts. Whenever they give you integral of the product of two functions, you try your best possible to express one as a derivative and one as an integral form. Then you use this formula. So I have these two problems here. I will illustrate it to you. So watch closely as I take you through. So in this problem, you have integral of what? S cos x dx. Remember that this x here is a monomial. Cos x is a trigonometric function, okay? For that reason, I have the product of two different functions. Until I use the integration by parts, I can't solve this anyway. So let's see how to apply the integration by parts in this manner. So I gave you the condition. The condition is that there should be the product of two different functions. So at this point here, let's u be equal to, we always differentiate the term which we think that it will arrive at zero or to be easier to differentiate. Then we choose the term which will be easier for us to integrate. So the choice is in your hands, but always take the parts that will make things easier. So let u be equal to x, right? So our u prime will be equal to 1. Now let v prime be equal to this one, cos x. That's what we do, cos x. So our v will be equal to what? The integral of cos x equal to what? Sin x. sine x. So once I have these parameters down, I just come for my integration by parts. So I'm going to say that integral of, right, u prime v, integral of u prime v should be equal to uv minus what? Integral of what? Uv prime. Okay, integral of uv prime. So here my integral of s cos x dx will be equal to uv. What is u and what is v? This is my u and this is my v. I'll just multiply the two, and that is going to give me x sine x, right? X sine x. Then minus the integral of uv prime. So my u is what? X. Then v prime becomes what? V prime becomes cos x, like this. So yes, so let's see here. As I said, uv minus what? Uv prime. Okay, uv prime. So this is my u and this is my v prime. So I think it should be u prime v instead. U prime v. So let me change it here. So let's see. Let's analyze here. Because we made initially we took what? U prime, right? We took u prime to be our cosine, right? Our derivative was what? The cosine. So remember, we took our u prime to be the cosine. So in this manner, our v prime is going to be what? It's going to be the other way around. So I'll have of integral of I'll have my u prime, which is 1 by my v sine x, sine x. So this is what you do. Initially, your uv will be your u and your v, right? This is because we integrated what? Our v. Minus here becomes our u prime v. U prime v. So take note of that. U prime. So this is equal to x sine x minus integral of sine x, and this will also give me x sine x. Integral of sine x is what? Negative cos x, so plus cosine x, right? Then plus c. That gives me my derivative. So in short, if you want to solve this problem here, you take your u, take your v prime, take your u prime, take your v. The next thing is what? You multiply this. Okay, you multiply this. Then minus integral of what? Multiply this and this. That's all. Just like this. That's all. Like that. If anything will confuse you, don't make this confuse you. Take your u, take your u prime v, then you cross multiply here, then also minus the integral of this, the product of these two. That's all. So let's see the second part of the problem. Integral of x multiplying e to the power x dx. Okay. So with this problem, let u be equal to x. Always u, which you can differentiate to 0. So u is equal to x and v will be equal to e to the power x, right? So my u prime will be equal to 1. My v prime is the same as what? E to the power x. Is that not it? Yep. So this look quite simpler, right? So as I said, our integral x e to the power x, the x will be equal to uv. My u is what? X, right? And my v is what? E to the power x. So I'm going to have x e to the power x. Now v prime and v are the same. So for here, when we get it, it doesn't matter, okay? But we actually choose u to be x and v prime to be what? E to the power x. Then you find v. So here minus integral of my u prime and what? And my v. And that is what? Integral of e to the power x. So here I'll simply get x e to the power x minus e to the power x. Then this was a definite integral from 0 to 1. 0 to 1, sorry. So from 0 to 1, I'll put my 0 and my 1 as my limits. When I put 1 inside, I'll simply get e to the power 1, go s is 1, minus what? E to the power 1. So e minus 1, e minus e, that will be 0. Minus the expression, when I put 0, when I put 0 here, you know that everything will be 0, right? So I'll simply put 0 as the power here, and I'm going to have negative e to the power 0. And that is going to give me, here will be 0, and here will be 0 plus 1, and that is 1 as my answer, right? 1 as my answer. So this is the concept of, so this is the concept of partial derivatives. Okay, so for this side, actually here being 0, and let's see something here. So whenever you are substituting your values, it's advisable to do your factorization so that it doesn't really mess up. So here, if you are factorize, you get e to the power x, open brackets, x minus 1, right? 0, 1, right? So let me cancel this. So here, when I put 1 inside, I'm getting e to the power 1, 1 minus 1, and that will be, everything will be 0. Minus, if I put 0, I have e to the power 0, right? Open brackets, 0 minus what? 1. Is that not it? So here is 0. So 0 minus of the expression, this is 1. And this is negative 1. 1 minus 1 times negative 1. So this becomes 0 minus minus 1. So yes, it's still positive 1. So we are going to get positive 1. So here too is 1. So anyway you do it, you should get the same answer.